So I'm going to help you understand how to do these calculations of pH and pOH. In the video prior to this, we talked about what pH and pOH were and what they represented. This is just an application of that math. So remember, these brackets mean molarity. So you had to learn molarity in your previous week's work so that you could use it for your acid-base chemistry. You also use it for all solution chemistry. In this application of this math, I am writing the H+, but of course there is no such thing, as you learned in your previous video, as H+ by itself. It's always a water molecule that's grabbed on to an extra hydrogen to form the hydronium ion. I just want you to be aware that you will see it in all chemistry written both ways, and it means the same thing. This lowercase p, so it is a lowercase p, is a math function that literally means take the negative log. This really for pH is to turn a very small number, an exponential number, into a more user-friendly number. It's nothing fancy, it's not complicated, it's just a math function to take an exponential number and turn it into a whole number that's easier to deal with. Okay. So you have all of the equations provided up here, but if you haven't used your calculator for log functions or you're not sure, you really are going to need some guidance with this. So let's look at these examples, okay? And you can work along with me. You can pause the video to see if you can get the same answers as we move along. So in this first one, we have given you the pH. So let's look at the relationships and figure out which one we want to find next. To me, if I'm given the pH, I'm going to go ahead and find the pOH next. The sum of pH and pOH is 14. So if I take 14 minus the pH, I'm going to end up with a pOH of 10.7. Now, as a beginning student, so pHs always have 2 decimal points. So try to remember to show 2 decimal points. Not a big deal right now if you don't. Your calculator certainly isn't going to do significant figures for you. pOH, no one thinks in the pOH scale. Even chemists think in the pH scale. But if you have a base, then you have a pOH. And with time, you will see if you have a larger pOH value, then you're going to be an acidic solution. So a pH of 3.30 is an acidic solution. Now you've got the concentration of the hydronium and the hydroxide ions. So if you look up here, so to find the pH or pH, you take the negative log of the concentration. Now we didn't have to do that here. But to find the concentrations, you take the antilog of the negative pH or pOH. The antilog, let me go ahead and clear this. Your antilog is your second function key and then hit your log. So you've got a 10, and if you're looking at finding your hydronium ion, that would be to the negative pH, so negative 3.30 is going to give you the exponential number 5.01 times 10 to the negative 4th. 5.01 times 10 to the negative 4th, and that unit is molarity. That's what those brackets mean. Notice right now, if we took the negative log of our answer, okay, we would come back up with 3.30. So taking the negative log of the concentration is our pH, and taking the antilog of our negative pH is our concentration. Believe me, this gets better and better as you move through it. You have 2 ways of finding the hydroxide ion. So you could take the equivalency that you've got H plus equivalent to OH negative equivalent to 1 times 10 to the negative 7 and solve. And you could take the product of these, which is something called KW, which is to the negative 14th. But most students will do exactly what they did with the H3O+. They're going to take the antilog second, try to get that up here, all second log of the negative pOH, which was 10.70. 10.70 is going to give you 1.99 times 10 to the negative 11. So 1.99 times 10 to the negative 11 moles per liter of hydroxide. Now, notice, you have a much higher concentration of the hydronium ion than you do hydroxide. -4 is much larger than -11. That means that you have more hydronium ion. That means you're acidic, which your pH supports. So look at the logic of your answers. Don't just punch numbers in. It's difficult when we don't get a chance to go into lab to make some acid-base solutions, but you can intellectualize this and look at what these numbers mean. Okay? So looking at your pH, pOH, hydronium, and hydroxide ion, you're looking for consistency. So let's look at the second problem. They've given you the pOH. So the easiest thing to do is to subtract the pOH from 14, 1.50. You can tell this is going to be a basic solution at 12.50 because your pOH value was so small. Okay? Remember, your hydronium ion concentration increases, okay, as your pH goes down. So a high concentration of hydrogen ion or hydronium ion has a low pH. This is an inverse relationship. Okay? So in your previous video, we talk a little bit about the concepts of this. Now we're applying the math. So if you're given a pH or pOH, find the other by subtracting from 14. Now you're going to find the hydronium ion by doing the antilog, which is the second log of the negative. Okay, since you took the negative log of the concentration, to find the concentration, you have to take the antilog of the negative pH. You really don't know log functions, so that's what makes it a little confusing. You get 3.16 times 10 to the negative 13. 3.16, again, 2 decimals times 10 to the negative 13 moles per liter. Again, look at the logic of this. That's our molarity. So if we wanted the pH, we would take the negative log of that answer, and we would come back with the pH. So the negative log of the concentration is pH. The antilog of the negative pH is the concentration. So now you would do the same thing with the hydroxide. So you should pause the video and punch this in yourself. When you look, you should come up with an answer of 0.32 moles per liter. Notice your hydroxide ion concentration is much, much larger than your hydronium, giving you a basic pH. You will never have a hydroxide or hydronium ion concentration that is 0. As one of these gets larger, the other gets smaller. If you look up at this equation where you see that they are in neutral water, both 1 times 10 to the negative 7 moles per liter, the product of that at 1 times 10 to the negative 14 is a constant. So if one of these values gets larger, the other always gets smaller, but never goes to 0. So now let's see if you can do this one by yourself. You've been given the concentration of 5.7 times 10 to the negative 9 moles per liter. You should try to look at this number and see if you can predict whether this is an acidic or a basic solution. So look up here at your neutral solution. Your concentrations would be 1 times 10 to the negative 7, and this is to the negative 9. So think to yourself, is that smaller than negative 7, larger? Do I have more hydronium ion? So pause the video and take a few minutes to calculate everything, and then I will go over it with you. So the first thing I would do with this is to take the negative log of that concentration to get the pH. So negative log, you can't see my negative sign down there. Negative log, let me clear that again. Negative log of 5.7 times 10 to the negative 9. So let me keep this up here. 5.7 times 10 to the negative 9 is going to give me a pH of 8.24. So you should have predicted a slightly basic pH. Okay. Then to find your pOH, you can subtract that from 14. So 14 minus 8.24 gives you a 5.76 for your pOH. And then 10 to your negative 5.76, so let's clear. So antilog of the negative 5.76 gives you 1.74 times 10 to the negative 6. So you can see in your final answers that you have solutions that are slightly basic, slightly more hydroxide ion than hydronium ion. Let's skip and go down to a whole number pH. If you did not get this from the last or first video, if you have a pOH of 4, then 14 minus that is going to give you a pH of 10. If you take the the antilog of negative 10, you're going to get 1 times 10 to the negative 10th. So I want to stay here a minute, and of course you're going to get 1 times 10 to the negative 4th. Now notice, if you have a 1 in your molarity and a power of 10, then this power of 10, this exponential number, becomes your pH. So if you have a pH of 10, you have a molarity of 1 times 10 to the negative 10, which gives you a pOH of 4 and a molarity of the hydroxide 1 times 10 to the negative 4. Notice if you took the negative log of 1 times 10 to the negative 4. So negative log of 1 times 10 to the negative 4 is always going to come out to be a whole number 4. So you can begin to predict if your number is very close. Okay, so here you've got 12.4. It's not exactly 12, so you're not going to have 1 times 10 to the negative 12. But let's look at this. Let's go from the pH to the hydronium ion. So let me clear. So that would be second log of negative 12.4. I'm expecting, okay, there's my 3.98 times 10 to the 13th. So let's put that in as the hydronium ion right here. 3.98 times 10 to the negative 13. So notice as this number got larger, then this exponent got smaller. That's your inverse relationship. If this was 12, this would be 1 times 10 to the negative 12, but being slightly above 12 moves it to the negative 13. Okay. All right, let's go back up here. So now you have the hydroxide ion concentration. So pause the video and see where you're going to go. Are you going to go from the hydroxide to the pOH, to the pH, to the hydronium? So figure out your plan, and then I will work it with you. Pause your video. All right, so if this is the hydroxide ion concentration, then the antilog of the negative hydroxide will be my pOH. So I will, messed you up there. That's my hydroxide ion concentration. So the negative log of that, the negative log of 4.80 times 10 to the negative 8 will give you your pOH of 7.32. You can see that it's pretty close to neutral there. See the negative 8 versus the negative 7. So then it's quick to subtract and get your pH of 6.69. So you're slightly acidic. So here you're slightly basic, here you're slightly acidic. Then to find your hydronium ion from your pH, you hit, let me go ahead and clear this, that would be negative log. Okay. I'm not sure why I'm messing you up. I don't mean to be. You've already got your pH. This is early morning messing me up here. So you've got your pH. So to find your hydronium ion concentration, you have to use your antilog. So second function log to the negative 6.69 gives you your 2.04 times 10 to the negative 7. So let's write that in. Let me scoot this over. 2.04 times 10 to the negative 7. So you can see you're very, very close to being neutral. Neutral will be 1 times 10 to the negative 7 for your hydroxide and hydronium ions. You are very close to that, but you're slightly more acidic at 6.69. So I'm going to slide the rest of these up, and I want you to finish filling in the remaining answers, and then we'll talk about them. All right, let's check your answers. So here, your first thing that you probably did was subtract to get your pOH, and then raise your 10 to the negative, so let's look, clear, second function log to the negative 1.6 gives you your 0.025 molar. So you could check those by negative logging this and coming back up with that, negative logging this and coming back up with that. Okay? And then, of course, the sum of those is 14. We did this one together. So here you were given the molarity of the hydronium or hydrogen ion. So if you negative log that, negative log your concentration, look at it again, 5.8 times 10 to the negative 11, 5.8 times 10 to the negative 11 will give you your pH of 10.24, again 2 decimal places. Subtract to get your pOH, and then to get your hydroxide ion concentration, 10 to the negative 3.76. So the antilog of the negative 3.76 gives you your 1.38 times 10, whoops, don't know where I'm getting that number, 1.74 times 10 to the negative 4. And down here, you were given your hydroxide ion concentration. So if you negative log that, you get the pOH. Remember, if it's hydroxide, you negative log it. It's the pOH for hydroxide. Subtract from 14, and then 10 to the negative 11.87, or antilog, the negative 11.87 gives you your concentration, put a molarity there, for your hydronium ion. So these are the skills that you need to be able to do to move from given one of these to finding all of them. So I will leave those up there. Here are your relationships, which have been given to you and will be given to you. And this sheet will also be attached following the video. So if you wish to print it out or just have it on your computer. So this will be directly under the video for you to bring up so that you don't have to write all these numbers up.